plus c. Of course, that's the antiderivative of x cubed times the square root of 16 minus x squared. Of course. Yeah, I don't know why. I don't know how you got into this class, Alexis. Now that gives you some appreciation of how far we've come, right? I mean, it's a pretty long problem. What do y'all think? Tell me. What are you feeling over there? Yeah. Shall we do another one? Of course we shall. Do you see why I'm not looking forward to trying to do the homework solutions to this section? But this is probably one of the more advanced integration techniques because it does involve so much. There's so much here that can go right and wrong for you. All right, so how about we do A? Let's do A. Integral 1 over x squared square root. Hey, Kiki. Do you remember in that last problem where you were looking and you said we might be able to peel off an x squared, like an x, and do something like that?
I don't think that was a bad idea.
Well, no, it's not a bad idea. But from the looks of the answer, I'm not quite sure this is going to work. You know what I'm saying? Like, how am I ever going to get to the answer from here? Maybe it does work, but yeah, I don't know. If you want, Kiki, you can mess around with that. If you get it with that method, let me know. Work it out. I'm not saying it does, but if you want to mess with it, yeah, on your spare time, which I know you have a lot of. All right, what about this one? So we start rolling through the Rolodex of methods, right? Basic substitution, integration by parts, trig substitution. If I see a square root with something squared and a number, right, then I'm thinking trig sub. So which of the three formats does this look like it falls into? The one that says square root. Oh, it's a squared plus x squared on the paper? Okay. That's the way it is on the paper? But addition doesn't matter, right? This is exactly the same? So that formula can work both ways. The other two can't. Subtractions cannot be flipped inside of a root. You can't pull negatives out of roots, right? Unless you're willing to deal with I. You don't want to mess with I. So that's the same thing. We have that format. For us, it's x squared plus 9, which means x squared plus 3 squared, which means A for us is 3, right? And when you have this form, what does the paper say you should do? What's the substitution I'm going to make? X is A, right? X is going to be A tangent theta, which for us in this problem will be 3 tangent theta, yeah? So we've figured out what form it is, what our A is, what the substitution should be, and exactly what it is for us. What do I do with this now? I'm going to write it down, then I'm going to take its derivative, right? And then I'm going to look at what that square root thing is. May I erase? You don't need that? Okay, so. So my x is 3 tan theta. Dx is 3 secant squared theta d theta. And then I said you need to look at the square root part that you made the substitution of, that x squared plus 9. All right, who wants that? Zach, how you feeling about that today? It's been a long, you've been doing math all day.
No. So,
You burned out?
no.
No, you're okay? Okay, so replace x squared with what? 3 tan theta, so it's underneath the root. So what do you get when you square this? So 9, right? 9 tan squared theta. It's what you get when you square x. Then plus what? 9. 9 can come out of both of these. And that leaves me tangent squared theta plus 1. Recognize that. That's secant squared theta. So square root of 9 secant squared theta, which is 3 secant theta. Do you all see that when we do this process, after we figure out what our substitution is, there's basically 1, 2, 3 pieces of information that we need. We need to know what the x is going to be replaced with, what the dx is going to be replaced with, and what the square root junk is going to be replaced with. Once you figure those 3 things out, you rewrite the integral. Got it? Let's see, who have I not called on in a while? I'm going to call on somebody. I don't know why, but on my end, it seems like everyone's talked already today. We'll go around tables again. How about that? So we'll start here. But if you answered me last time, you can't answer this time. Yes, that's what we'll do. So from this table, from this think tank over here, I want you to tell me how to rewrite this integral in terms of theta. So whoever. Go ahead, yo.
Do 1 over, will we do a tangent theta, or replace x with the a tangent theta?
Yes. But
Oh,
what is
tangent
that?
Theta, I'm sorry. I was looking at
Yeah,
the far
yeah.
right corner.
We'll get rid of that then. We'll get rid of that.
So we replace that with 3 tangent theta.
Which would
squared.
become, okay, so you want, I'll just write it as squared. 3 tan, you want to square it now?
Yeah.
Okay.
9 tangent squared theta.
So this x is being replaced with 3 tan theta. It's becoming 9 tangent, you said square theta,
Yes, sir.
times,
The inside, which would be
what does the whole root junk thing turn into?
turns to 3 secant.
3 secant theta. Next table, going back. What's next?
Squared theta.
You answered last time, didn't you? Sorry.
Replacing the dx.
You got to replace the dx with
3 secant squared.
3 secant squared theta. Matter room. Are we done, Karen? Yes?
No, we can cancel.
Okay, yeah, but I'm saying as far as plugging in, yes, we're done? Okay. All right, so you want to cancel? Tell me what's going to go away here, what we'll be left with here.
Secant theta now.
Secant, so you're just going to get rid of the squared and that secant, right? Any other cancellation here? These 3's cancel. That's nice. You want to take care of that 9 for me, Karen?
So you can fill it out.
Okay, as 1/9. Good. And I'm left with a secant theta on top. And and a tangent squared theta on the bottom, d theta. Moving on. This one's a little tricky. So I'll open this up to the whole class because this next step's a little tricky.
Are you going to write it out differently, like 1 over cosine theta times sine square theta over cosine square?
I am going to do that. But why am I not going to do this thing with secants and tangents that we just talked about? I need secant to an even power, which I don't have. Or I need tangent to an odd power, which I don't have, right? That's not going to work. So when you run into a situation like this, where you really can't figure out what's going to happen here, go turn everything in terms of sine and cosine. So usually something's going to work out for you. All right, here we go. So want to turn the secant on top to 1 over cosine theta. Want to turn the tangent squared theta. Tangent is what? Sine over cosine. And squaring them, so sine squared theta over cosine squared theta, then d theta. So I've got a complex fraction. Fraction over a fraction. All right, now we'll move to the next table. We've got Kelly, Vanessa, and Ruben. I knew your names. I was looking this way. I knew all of your names. That's pretty good. I mean, that's a milestone for me. All right. Okay. So what would you get? If you do this.
Cosine theta over sine squared theta.
Yes. Everyone agree? Cosine theta over sine squared theta. We'll stay at that table. We're whittling down the members. Vanessa or Kelly, any idea on the technique to get that one? Clear the RAM. Okay, what do you want to use as a basic substitution here? What? Okay, so why sine? Why would we want sine? Derivative's up there, right there, right? Okay. So we're going to do a u is cosine. U is sine theta. I can't talk today. U is sine theta. Du is cosine theta d theta. And so we should be getting 1/9 integral 1 over u squared du, which is the same as u to the negative 2 du. And moving back around. Ethan, Sean, let's see, who's talked over there? Sean, did you answer already? Who answered the last one? Did I skip? I always skip that table. All right, anyone over there? Antiderivative of u to the negative 2. Oh. If the pressure's on, your brain shuts down, right? Just power rule there, right? So add 1 to the exponent. In front of it, 1 over that same number. So you get negative, and put negative 1 u to the negative 1. Is that fair? Do that. Plus c. And then that's really negative 1 over 9u plus c. That's the same thing. U to the negative 1 is 1 over u. 9's already down there, so I'll just throw them together. I think we're there. But we have to get back in terms of x, okay? So let's first go to theta, which we already know what u is, right? U is sine theta. So this becomes, man, I should have just left that out there. Negative 1/9 times 1 over sine theta plus c. I peeled it back apart because I realize now I need to substitute back. So I take the negative 1/9 out here. That left me 1 over u. 1 over u, u is sine theta. What is 1 over sine theta? It's cosecant theta, isn't it? Now you could leave it as sine theta down there and then go back to x, but I'm just going to write out what it is. This is negative 1/9 cosecant theta plus c. And now I need to get back to x. So where do I look to get back to x? Where do I look at? My initial substitution, what this technique told me I needed to use. And what was that initial substitution? X was what? 3 tangent theta? X was 3 tangent theta. How am I going to use that? Divide both sides by 3 to create a ratio. And then from that, make a triangle. And label the sides how? Opposite is x, adjacent is 3, and that means the hypotenuse is square root of x squared plus 9. Wasn't that the ugly piece that that's that piece, this piece right here, the square root part of the trig sub that keys you off in the very beginning as to which of the 3 to use? You know what I'm talking about? The square root of the a squared plus x squared, or a squared minus x squared, or x squared minus a squared. That thing will always appear somewhere on your triangle. Always.
Is it always going to end up being?
It won't always end up being part of your answer. But if you draw a triangle, it's going to have to be there. All right, and I wanted cosecant. What is cosecant's the reciprocal of sine? Hypotenuse over opposite. So it's that over this. That's it. So we get negative 1/9 times the square root of x squared plus 9 over x plus c. I don't know about you, but you know, it's good stuff. Now there's one particular type of problem that I want to show you. We've got 20 minutes, so I think I have time for one more. Yes. Come on. This one's not on our sheet there. Okay, I'm doing this one. I'm just going to do this one on my own here. Something's going to happen in here. It's going to be kind of nice. I'm doing a different problem, yeah. All right, so you go through and you're like, okay, is this a basic substitution? Do I see something as derivative? No, I don't. Is it integration by parts? No, I don't think so. I don't know. right? You keep on, with time, you start to just get that, I guess. Omit, cancel. But it has a square root, right? And so which of the formats does this fit into? A squared minus x squared, right? And for us, it's 3 minus x squared, which means that it's the root of 3 squared minus x squared. It just so happens that that's not a perfect square, but that doesn't stop us from being able to use the formula. So for us, a is root 3. What is the substitution that we make in the case that we have this? X is what? What is it? A sine theta? Sure? Hold on, which one are we looking at here? Okay, a sine theta. It's not the last one. It's not x squared minus a squared. I'm not giving you that one right now, okay? The x squared minus a squared, we'll do one of those next class. The reason is because I want you to see this happen, all right? What's about to happen? X is equal to root 3 sine theta. There's what we've got. Okay? So I'm going to go ahead and write this information down. Everything was just to get to that piece right there. Now I'm going to write that down. I'm going to take its derivative, and I'm going to look at that root thing and see what it simplifies to be. How about we take the next 7 minutes to see how far you can get on this? You don't need to turn it in or anything, but let's see how far you can go with this problem in 7 minutes. Let's see, is Joshua here? No? I'm also going to pass around the sign-in sheet. Start here. Make sure that gets around. Just initial next to your name, please.
The only portion of this having issues with, like I was having issues with it. I just kind of went along with it beforehand, but if you could like clarify, like
Let me see what you did
this
here.
portion here,
So,
then maybe like pull this out, but then where does this squared go? Like, I'm not sure.
okay, so let me do it right here. You go square root 3 minus now x squared. So you square this, right? So square that and you get what?
3.
3. Square that. I think you might have missed that. You don't have that written down. You don't have a squared on it.
Yeah.
Okay. Now each of these has a 3.
So that's how you make the square root go?
Well,
Is-
not yet.
is it squared?
Not yet. This right here is root 3, right? I'm sorry, square root 3. Pull the 3 out. That's 1 minus sine squared theta, right? If I pull a 3 out of each of these.
What happened to, I thought this was just originally, it was supposed to be root 3, wasn't it?
No, no.
Because you're replacing this with x and you have,
No, no, no.
you get this 3 from this.
This, because this is what in the problem told us to make this substitution, right? To make that substitution, use x equals a sine theta. This is the thing that told us to do that.
So we're manipulating this thing.
Yeah, all we're doing is taking a look at that. We're saying, well, if we're going to make that substitution, then what does that turn into? And that's what we're doing here. We're saying this is going to turn into this because that's what I'm going to turn x into,
Okay.
which turns into this, which turns into 3. This is cosine squared theta. Now, in the previous examples, this was a perfect square. It was 4 or 9 or something. Here it's not, so you can't.
Be root 3.
Root 3. But then what's the square root of cosine squared?
Cosine.
Cosine. So that's where the root goes. It goes away because it's multiplication here. It started out as subtraction, now it's multiplication.
Yeah, see, I thought you were trying to manipulate
Nope.
this portion. Right
Nope,
here.
I'm just, it has nothing to do with these. Okay, this is this is our substitution. Here it's derivative. And by the way, the thing we're really looking at here turns into that.
Yeah, because you have to find a, and then x, and then dx, and then the thing.
Yeah.
Okay.
Yeah.
Yeah, looks like that's okay so far. Okay, so now I got perfect. So you're just manipulating the thing that
That's right.
keyed you in on doing this. Okay, yeah, see, that's where I was confused the previous few problems.
Okay, good. As long as that's clear. Are y'all getting anywhere? Does anybody have it down to the trig integral yet? Of what the trig thing, like this with trig stuff in it? Anyone there yet? Yeah? Okay. Just give another minute. Okay, I need enough time to finish this problem out, so let me go ahead and pick up where I had left you. This was going to be our trig substitution, right? We're all okay with that, right? And then take the derivative, so dx, root 3 comes down, derivative of sine of theta is cosine theta d theta. That we always do, right? The next thing you look at that is not connected to this at all, really. I mean, it is, but I'm not like doing the next line or anything like that. I'm just saying, okay, that square root part of the problem that caused you to use this substitution, let's check out what that is. Like, what is this? Because we need to substitute this out. So that's square root of 3 minus x squared. What is x? Root 3 sine theta. So if I take root 3 sine theta and I square it, right? I square the root 3, which gives me 3. I square the sine theta, which gives me sine squared theta. Then from here, they both have a 3. I factor a 3 out. That leaves me 1 minus sine squared theta, which is cosine squared theta. And now I take the root. But I can't take the root of 3 because it's not a perfect square. So I just have to leave it as root of 3. I can take the root of cosine squared theta. That's just going to be cosine theta. So This part right here, this ugly thing, is going to be replaced with root 3 cosine theta. So now I'm going to rewrite the integral. The integral becomes, what is the root 3 minus x squared become? Square root 3 cosine theta. That's it. What's dx going to become? Square root 3 cosine theta d theta. So look, you have got to be extremely careful. You know how these things, dx, d theta, I know on some of your work, you'll forget about the dx and the, you forget these things. Do you see now, if you forget that, you're going to miss an entire piece of the integral? So it's not just something we like to slap on there just to have on there just for fun. It's part of this substitution process. We clear on everything? All right, let's take the root 3 times root 3. Let's take that outside. That's going to be what, 3? And then what do we have inside? Cosine squared theta, which we will use integration by parts. No, that's the one that you had on the test, right? It's the one everyone freaked out about. Not everyone. Some people got it. Right, that's what we have. How do you solve an integral that has cosine squared in it? Use the half angle identity, or what I call the power reducing formula. This is the one where we use, I think the formula, the way I wrote it, was something like this. Remember that formula? No. But instead of x, we're using theta, right? Make sure you keep track of that. You can't mess that up now because, look, we're at theta, we're not at x. So this becomes, let's see, 3 integral 1/2 1 plus cosine 2 theta d theta. Take the 1/2 out. And yeah, we're going to just integrate that. But this is the part of the problem I wanted you to see. Something's about to happen that we haven't had happen, which is interesting. Okay. We can find the antiderivative of each one of these term by term, right? What is the antiderivative of 1? Theta, because our variable is theta, right? Not x. See, again, be careful. So we have 3/2, then theta. What is the antiderivative of cosine 2 theta? 1/2 sine 2 theta, right? Plus c. Hey, we didn't need a u substitution in this one, right? We didn't need a u substitution. We actually just have to go back to x. We're only one variable away. Do you understand? In the past two problems, we were always like 2 variables away. So we just got to go back. But do you see the problem? My answer is in terms of theta, the angle theta, whatever that is, and sine 2 theta. My original problem didn't have 2 theta in it, did it? What is the thing that I told you to go back and look at, though, when you get to this point? Your original substitution, which was x was root 3 sine theta. I said draw a triangle off of this, yes? So x over root 3 equals sine theta. Do y'all see what I'm saying? You don't know what sine theta is. You know what sine theta is. You don't know what sine of 2 theta is. And that's what you need for the answer. Yeah? Also, you don't know exactly what theta is unless you do something over here. But let me draw my triangle. Theta x root 3. Is that right? I'm going to need this side. I may as well get it now. What do you think it's going to be? Square root of 3 minus x squared. Didn't I tell you that that square root thing is going to appear on your triangle? There it is. All right. Let's resolve theta first. How can I get theta? Take this right here. take arc sine of both sides. Right? Arc sine of both sides. So using this information, I can take the inverse sine on the left and the inverse sine on the right. The inverse sine of theta is going to be theta. As long as theta, we have domain restrictions, but we haven't been messing with those too much anyway. So that's theta, right? And then how are we going to deal with sine 2 theta?
Plug in the 2 inverse sine.
Oh, you mean multiply this by 2, and then this by 2, and then plug that in? That'd be more work than we have to do. You all remember what this is, right? That's really 2 sine theta cosine theta, isn't it? This is really 2 sine theta cosine theta. Right? This is really 2 sine theta cosine theta. That's what this is. And then the 2 and the half are going to cancel. Do you know what sine theta is? Yes, and you know it off the triangle. Do you know what cosine theta is? This right here. Jason over hypotenuse. So we have everything we need. Here it comes, final answer. The answer is 3/2, parentheses, theta, which was arc sine of x over root 3 plus the 1/2 and the 2 went away, right? Sine theta, which is x over root 3 times cosine theta, which is root 3 minus x squared over root 3. All of this plus c. We made it. You could put these root 3's together and make that a 3. You could then distribute the 3/2 through, and I think the 3 would cancel. Like this 3 up here would cancel with the 3 down there. We're there. All right, those 2 problems up there, I think I'll have to start maybe next class with those. Here's the homework for this section. Remember that if the integral in the homework has a number up here and a number down here, that you ignore the numbers and just do the problem, but then of course the answers are not correct in the back of the book. They'll have a numerical answer instead of a function, but you can still do it. Yes?
Where's the 2?
Which 2?
Sine theta, cosine theta, right?
The 1/2 in this 2,
Oh,
right? Because this generates a 2 sine theta cosine theta, but there was a 1/2 there. Wasn't there a 1/2 there? Okay. Yeah, because when we did the antiderivative. All right. Well, I would not expect that you could do all of that homework yet, but you should at least get started on that homework. I haven't even started it. The 39 through 61 are problems like this. The first few, they tell you what the substitution should be, like x is 3 sine theta, the first 3 of them, or first few of them. And then from 43 on, they don't tell you what the substitution is. Not that it's super hard to get, but. Have a good day.